Hello, dear students. So we are going to discuss the mathematics JEE paper that you just wrote on 10th June 2023. The paper is mainly based on differentiation and it's quite a straightforward paper. So let's get started right away. So the first question. Suppose that f of x minus f of 2x has a derivative 5 at x equal to 1 and derivative is 7 at x equal to 2. Now they're asking what is the derivative of the function f of x minus f of 4x at x equal to 1. So very straightforward question. Because they're asking for a derivative, naturally we'll have to differentiate the first equation, which is f of x minus f of 2x. So when I differentiate that, I'll get f dash x minus 2 times f dash 2x. And now substitute x equal to 1, x equal to 2. So when I substitute x equal to 1, I'll get f dash 1 minus 2 times f dash 2, and that is given as 5. Then substitute x equal to 2. Then you'll end up getting f dash 2 minus 2 times f dash 4 is equal to 7. And they're asking us to find derivative of this function. So let us differentiate that function and substitute x as 1. So when I differentiate, I'll get f dash x minus 4 times f dash 4x. Right now, when I have to substitute x as 1, so I need to find out the value of f dash 1 minus 4 times f dash 4. So now how do we solve this? We know these two equations. From these two equations, I'll have to get this. Quite obvious. I have to eliminate f dash 2. That means I will have to multiply the second equation by 2. And then add both. So when I add both, I will end up getting f dash 1 minus 4 times f dash 4 is equal to 5 plus 7 into 2. So that is 14. So 5 plus 14. So the right answer here is option A, 19. Very straightforward question. Let's move to the next one. The next one is also a direct question. They're asking us to find, they have given f dash 0 is 18, right? So this is our f of x and f dash 0 is given. So directly differentiate using product rule. Let us see what we get. When we differentiate, we get f dash x is equal to derivative of kx plus e power x will be k plus e power x into h of x, and derivative of h of x is h dash. So I keep the first function as it is and differentiate h alone. So this is f dash x. Now substitute x as 0. So we end up getting f dash 0 is k plus e power 0. E power 0 is 1. And h of 0. H of 0 is given as 5. Then in the second term, because x is 0, the k into x won't come into picture. It will simply be e power 0, which is 1. And h dash 0 is minus 2. So f dash 0 is already known to be 18. So I'll equate this whole stuff to 18. And when I transfer this minus 2 to the other side, it becomes 20. So k plus 1 into 5 is 20, or k plus 1 is 4. So k will be 3. That is option C. So again, a easy question, straightforward one. Let's move to the next one. So the next question is another direct trigonometry related question. We have already discussed whenever we see root of 1 minus t, we'll have to substitute t as cos theta. Why? Because 1 minus cos theta becomes 2 sine square theta by 2. And similarly, 1 plus cos theta becomes 2 cos square theta by 2. So when I make that substitution, t as cos theta, I will end up getting e power x is equal to 1 plus t, right? Root of 1 plus t becomes root 2 cos square theta, right? Root of 1 plus t can be written as root 2 cos square theta by 2, or simply root 2 cos theta by 2. Similarly, root 1 minus t can be written as root 2 sine theta by 2. So when I make that substitution here, I will pull out root 2 common. So I'll get cos theta by 2 minus sine theta by 2 whole divided by root 2 into cos theta by 2 plus sine theta by 2. And now if you divide each term by cos theta by 2, we end up getting e power x is 1 minus tan theta by 2 by 1 plus tan theta by 2. And this is the famous identity, tan of pi by 4 minus theta by 2. So that is e power x. So then how to get x now? So to get x, take the e to the right hand side. So you will get x equals ln tan pi by 4 minus theta by 2. Now, when t is half, right, we are substituting t as cos theta. So half is equal to cos theta. That means theta is nothing but 60 degrees. So keep this in mind. In the end, we may have to substitute for theta. So now what about this y? So tan y by 2. I can write tan y by 2 as root of 2 sine square theta by 2 by 2 cos square theta by 2. So I'll end up getting tan y as tan theta by 2. That means I can cancel the tans on both sides, can cancel the half on both sides. I can say y is equal to theta. Now how to find dy by dx? Use parametric differentiation. So dy by dx is nothing but dy by d theta by dx by d theta. Now dy by d theta, when you differentiate this, you'll end up getting as 1. And what is derivative of ln tan pi by 4 minus theta by 2? Derivative of log is 1 by tan pi by 4 minus theta by 2 into derivative of tan will give secant square, and derivative of pi by 4 minus theta by 2 will give minus half, right? So I'll write that minus half here. Now denominator will go to the numerator. So I'll end up getting minus 2 tan pi by 4 minus theta by 2. I shall write tan as sine by cos and the secant square, which is in the denominator, right? I will transfer it to the numerator and it will become cos square pi by 4 minus theta by 2. So the cos term will get cancelled. Then I'll be left with 2 sine theta cos theta, which is sine 2 theta with a minus sign. So finally, I'll end up getting minus sine 2 theta. And what is 2 theta? 2 theta is nothing but pi by 2 minus theta. I'm multiplying this whole angle by 2. And now when you substitute theta as 60 degrees, 90 minus 60 is 30 degrees. So minus sine 30, which is minus half. So this is also an easy question. So the next question, 64th one, is again a straightforward one. They have given y square is equal to ax square plus bx plus c, and they're asking us to see whether y cube into d square y by dx square is a function of x or y alone, like that. Okay, so start off directly differentiating. Then we end up getting 2y y dash is equal to, when you differentiate ax square plus bx plus c, you'll get 2ax plus b, right? From here, get an expression for y dash. So what is y dash? Y dash is nothing but 2ax plus b by 2y. So keep this in mind. We may need this when we differentiate this for the second time. So now, how do I differentiate this further? I use the product rule. So when I use product rule, I will end up getting 2 times derivative of y dash. Use product rule. So when you differentiate y, you'll get y dash. So y dash into y dash. So that will give y dash whole square plus keep y as it is and differentiate y dash. So you'll get y double dash. And this whole thing, we equate it to the derivative of 2ax plus b, which is simply 2a. So 2 gets cancelled. So then I'll end up getting y double dash is equal to a minus y dash whole square. Now in the question, they're not asking y double dash into y. They're asking y double dash into y cube. So I multiply by y square on both sides. So when I multiply by y square on both sides, I get y cube into y double dash is equal to a y square minus y square into y dash whole square. But for y dash, I'm going to substitute this, right? When I do that, I'll end up getting 2ax plus b whole square by 2y whole square. So y square will get cancelled. So here I'll see I'll have only x terms, but there is a y square here. But I know that y square can be written as a function of x alone. So that means y cube into y double dash will be a into ax square plus bx plus c minus 2ax plus b by 2 whole square. So the right answer is It's a function of x alone. Right. Let's try expanding also to see if it's a constant. When you expand, we end up getting a square x square multiplied by 4. Then we end up getting, I'm taking LCM also here. Then we end up getting 4abx, then plus 4ac, and minus 4a square x square, then 4abx plus b square, whole divided by 4. So you'll see it is not a function of x also, because 4ax square, 4a square x gets cancelled, 4abx gets cancelled. So the right answer is it is a constant. So although one step before we were looking at as though it is a function of x alone, unless you simplify, you may not end up with the right answer. So we move on to the next one. Next is an interesting question. They have given these two conditions. With these two conditions, you will need to find what is the relation between x and y. Okay, so currently x and y are written as a function of t, but we need to get a relation between x and y. So how do I get that? I'll have to square this first. So when I square this, I'll end up getting x power 4 plus y power 4 plus 2x square y square, a plus b whole square, a square plus b square plus 2ab. And when I do the similar thing on the RHS, I'll get t square plus 1 by t square minus 2. So now if you look at the second equation, they are saying this and this are equal, right? Because these two are equal, I can cancel off this with this. So what I will be left with is x square y square is equal to 2x square y square is minus 2, or y square is simply minus 1 by x square. So this is the function. Now differentiating this is no big deal. So when we differentiate, we get 2y y dash is equal to minus of minus 2, which is plus 2 by x cube. So 2 gets cancelled. Transfer the x cube to the LHS. So we end up getting x cube y dash is equal to 1. So that is option B. So the next question, 66th question. This is again an easy one. All you need to know is what happens to cos inverse cos x. So cos inverse of cos x, right, is x only if x is in the principal branch. That means x should lie between 0 to pi. Now because phi pi by 4 lies in the third quadrant, it is pi plus pi by 4, right? Now how do I make this go to the second quadrant? So all I have to do is, if I instead of phi pi by 4, if I write it as 2 pi minus phi pi by 4, because we know that cos theta is equal to cos of minus theta, right? Cos of minus theta is same as cos theta. That means cos of 2 pi minus theta is same as cos theta. So the first step is I will try to write phi pi by 4, cos phi pi by 4. I'll write it as cos of 2 pi minus phi pi by 4. Now why do I do this? Because when I write 2 pi minus phi pi by 4, and take LCM, you will get 3 pi by 4. That means it lies within the principal branch. So cos inverse cos x in this question will be written as cos inverse cos 2 pi minus x. And then you can cancel this because 2 pi minus x lies in the principal branch. So this is our function. Y is nothing but 2 pi minus x. So dy by dx will be equal to minus 1. So this is also a direct question. Now moving on to the 67th one. So this is on successive differentiation. Obviously, when you see a power 1 by m on the LHS, the first step is raise both terms to the power m. So when I raise both to power m, I'll end up getting y is equal to x plus root 1 plus x square whole power m. Now when you differentiate on both sides, we end up getting y dash is equal to m x plus root 1 plus x square power m minus 1 into derivative of the inside function. So derivative of x is 1 and derivative of root 1 plus x square is 1 by 2 root 1 plus x square into derivative of 1 plus x square, which is 2x. So the 2 gets cancelled. Now, one interesting thing you will see, whenever you have x plus root 1 plus x square, and when you differentiate it, right, you will see, once you take LCM here, you will get x plus root 1 plus x square again, right? So you'll end up getting x plus root 1 plus x square again, because there is a x term here, and root 1 plus x square, when you take LCM, you'll get that. But the only thing is, the original function, if it is x plus root 1 plus x square, its derivative is also the same, but divided by root 1 plus x square. So the numerator, this whole part is simply y. You get back the original y, isn't it? So we end up getting y dash is m y by root 1 plus x square. That denominator I'll cross multiply here. And then I'll square on both sides. So I'll get 1 plus x square into y dash whole square is equal to m square y square. Now I differentiate once, then I'll get the answer. So when I differentiate using product rule, I'll end up getting 2x y dash whole square plus 1 plus x square into derivative of y dash whole square, that is 2y dash y double dash. And when you differentiate on the RHS y square, you will get 2y y dash. So now 2 can get cancelled everywhere. Y dash can get cancelled everywhere. So now you look at what is left is what is being asked. Xy dash, that's there here. And 1 plus x square y double dash, that's there here. So both of them put together will give you m square into y. So that's again option A, m square into y. So quite straightforward. All are kind of easy questions to handle. Next one again. G is the inverse of f. They have given f dash as sin x. So what do you think is f of x? What function, when you differentiate, you'll get sin x? Obviously, f of x must be minus cos x. That means the original function is y is equal to minus cos x. So if I try to take the inverse, I'll get minus y equals cos x, or x is equal to cos inverse minus y. So this is my g. So what is g of x? G of x is cos inverse minus x. Now they're asking what is g dash. So g dash will obviously be derivative of cos inverse, which is minus 1 by root 1 minus x whole square, into derivative of minus x, which is minus 1. So I'll end up getting 1 by root 1 minus x square. Now, if I look at whether option A will be the right answer, let us see that. What is option A saying? Option A is saying cosecant of 1, cosecant of g of x. And what is g of x? G of x is cos inverse minus x. I can write cos inverse minus x as sine inverse root 1 minus x square, which further I can write as uh, cosecant inverse 1 by root 1 minus x square. And then this will get cancelled, and I'll get exactly the same answer as I got by directly differentiating g of x. Isn't it so? Option A here is the right answer. Because when I substitute g of x as cos inverse minus x and evaluate what is cosecant of that, I will end up getting 1 by root 1 minus x square. So it is option A. Moving on, the 68th question. 68th question is a little interesting one, easy. So here they're saying y is equal to f of x is symmetrical about y-axis. That means symmetrical about y-axis means it should look like this, a parabola kind. Basically, it should be x power 2n, x power 2n. And g of x is symmetric about the origin. That's like y equals x cube or x, like this. So that g of x is x power 2n plus 1. Now they're saying h of x is product of both. So if h of x is product of both, then h of x is nothing but x to the power 4. I can say this has 2m maybe. So h of x is x to the power 2n plus 2m plus 1, right? So now they're telling us, they're asking us to differentiate 3 times. So it's obvious that when you differentiate 3 times, what you'll be getting is 2n plus 2m plus 1 into 2n plus 2m into 2n plus 2m minus 1 into x to the power 2n plus 2m plus 1 minus 3, because when you differentiate every time, power reduces. So this is what you'll get at x equal to 0. So when you put x equal to 0, irrespective of m and n, you get answer as 0 for all cases, except when this whole term is already 0. Because if this whole term is 0, then anything per 0 becomes 1, right? So therefore, when will this whole term become 0? Obviously, when m and n both are 1, right? When both are 1, then you'll get here, sorry, when m is minus 1 or when m is 0, n is 1. When you substitute that, so when you do that, you'll get 3 minus 3. So at that time, you'll get a constant as the derivative. Rest all times, you'll get the derivative as 0. So because it depends on the value of m and n, the right answer here is it cannot be determined. Right? If you take f of x as x square, g of x as x, so h of x will be x cube. Now, when you differentiate it 3 times, you'll end up getting 6. But in all other cases, you'll get answer as 0. So I hope this is clear. We move on to the next question. So the next question is again a straightforward one. Whenever we get root of 2x square minus 1, of course, we don't need anything, I think, here. Let's read the question. Y is equal to f of x square. They're asking dy by dx. So let's directly differentiate. What is dy by dx? Dy by dx will be f dash x square into derivative of x square, which is 2x. Now put x equal to 1. So you'll get f dash 1 into 2. Now for finding f dash 1, they have already given this. So here just substitute x as 1. So f dash 1 you'll end up getting as 1 into 2. So the answer is 2. Very easy question. Now this next question, 71. There is a trick here. They have given an expression, and that expression contains another variable apart from x and y. There is another constant a, right? And in the options for dy by dx, since none of the options contain a, I can assume a as any value. So the simplest thing is assume a as 0 itself. So when you assume a as 0, you can either do that or you can assume a as even 1. So let's assume a as 1. Then we end up getting root 1 minus x square plus root 1 minus y square is equal to x minus y. So now bring all the y terms to one side. So you'll get y plus root 1 minus y square is equal to x minus root 1 minus x square. So now when you differentiate, you'll get y dash into 1 plus 1 by 2 root 1 minus y square into minus 2y y dash. That y dash is already taken out. And here you'll end up getting 1 minus 1 by 2 root 1 minus x square into derivative of this, which is minus 2x. So 2 gets cancelled. Here also 2 and 2 gets cancelled. So then I'll end up getting y dash is nothing but root 1 minus y square minus y. Y dash into this is equal to root 1 minus x square plus x by root 1 minus x square. So now y dash will eventually turn out to be root of 1 minus y square by 1 minus x square into we get x plus root 1 minus x square by root of 1 minus y square minus y. So now when I try to rationalize this, right, I try to multiply by its conjugate. Why? Because I want to bring it to the original form here. I'll try to rationalize one of them. Probably I'll try to rationalize this. So I'll multiply this by its conjugate. So when I multiply by its conjugate, I'll also have to divide by its conjugate. But I know that x in minus root 1 minus x square can be written like this. So this will be root 1 minus y square by 1 minus x square. And this is like a plus b into a minus b, which is a square minus b square. So you'll see x square will get cancelled. No, it isn't it? And here, let's see if we substitute a as 0. Would that make it more simple? Let's see. So if we substitute a as 0, I'll end up getting root 1 minus x square equals minus root 1 minus y square. So that means when I square on both sides, I'll get 1 minus x square equals 1 minus y square, or x equals plus or minus y. So when I directly differentiate this, I'll end up getting, when I differentiate this directly, I'll end up getting x equals plus or minus y, right? So now when I differentiate this directly, I'll end up getting 1 by 2 root 1 minus x square into minus 2x is equal to 2y by 2 root 1 minus y square into y dash. So 2 gets cancelled. So I'll end up getting y dash as minus root of 1 minus y square by 1 minus x square into x by y. So from here, I know that x must be equal to y. X must be equal to y here. So then when I substitute that, or x should be either y or minus y. So when I substitute that from the options, it's evident that it must be of the form either b or, yeah, root 1 minus x square should come in the denominator. So the answer is option B, because x and y get cancelled with the minus 1, because x can either be y or x can be minus y. So if x is minus y, this minus and minus will make it plus. So it is option B. It was a slightly tricky one. Next one, when they give f of x square is equal to x cube, that means f of x will be x power 3 by 2, isn't it? When I replace x square with x, then here also I have to reduce the power by half. So once I know this, either I do it like this or I do it directly also. directly they're asking f dash 4, right? So differentiate on both sides. So f dash x square into derivative of x square, which is 2x, is equal to 3x square. So 1x will get cancelled. So now they're asking f dash 4. F dash 4 means I will have to substitute x either as +2 or -2, but they are saying f is defined only for positive real numbers. So x has to be +2. So if x is 2, then I get f dash 4 into 2 is equal to 3 into 2. So 2 gets cancelled. So f dash 4 will be 3. We move on to the next question. So the bottom line there is, in case they had not mentioned x can be only positive, then the answer would turn out to be cannot be determined, because x can either be +2 or -2. Okay. So here next question. G is the inverse of f. That means g of f of x is x. So now when I differentiate, I'll get g dash f of x into f dash x is 1. So g dash f of x will be 1 by f dash x. Now when I again differentiate this, I'll get g double dash f of x into f dash x is equal to, when you differentiate this, you will get minus 1 by f dash x whole square, chain rule. This is like 1 by x, 1 by k. 1 by k derivative is minus 1 by k square into derivative of f dash, which is f double dash. So finally, when I take this to the denominator, I will end up getting option A as the answer. The next one is also direct and very easy. We draw a triangle whose cot theta is this, right? Adjacent is √1 minus x, opposite is √1 plus x. Either we do that or just substitute x as cos theta. So when you substitute x as cos theta, here you will get root of 1 minus cos theta by 1 plus cos theta, which is tan theta by 2. So cot inverse, I can write tan theta by 2 as cot of pi by 2 minus theta by 2. So cot inverse of this whole thing, cot, so I'll end up getting sine square pi by 2 minus theta by 2. And sine square pi by 2 minus theta by 2, or sine of pi by 2 minus theta by 2 whole square, which is cos theta by 2 whole square. And theta is nothing but, we have written x as cos theta. So now when we try to differentiate this whole thing, or better, we try to write it in the form of a right angle triangle, that will be also quite easy. Cot inverse, right? Can I write it in terms of sine inverse? So I'll call this as theta. I'll put this as 1 minus x. I'll put this as √1 plus x. So this will be, when I square this, and square this, I will end up getting root 2, right? So I can write cot inverse of this as sine inverse root 1 plus x by 2. And there is a sine also outside, and whole square is there. Sine square means sine of this whole square. This will get cancelled. So when I square, I'll end up getting y as 1 plus x by 2. So then dy by dx will simply be half. So that's a more easy way of doing it. 75th question. G of x is a quadratic which is positive for all real values. That means a quadratic ax square plus bx plus c is always positive when discriminant is less than 0 and a must be greater than 0. So these are the two conditions that we need to remember. So for time being, let's assume a as 1. So our quadratic is simply x square plus bx plus c. Now g of x is x square plus bx plus c plus derivative of f of x, which is 2x plus b plus second derivative, which is 2. Now we need to evaluate this discriminant. We know that b square minus 4c is less than 0. Now using that condition, let us try to analyze this. So I can rewrite this as x square plus b plus 2x plus b plus c plus 2. So iska discriminant will be b plus 2 whole square minus 4b plus c plus 2. So I'll end up getting b square minus 4c. Along with that, I'll get a plus 4b and minus 4b, which will get cancelled. Then I'll get plus 4 and minus 8, right? So plus 4 and I'll get minus 8. So I'll end up getting minus 4. So if this is less than 0, this obviously will be less than 0. That means g of x will certainly also be positive. So this will be less than 0. So when the discriminant is less than 0, g of x is going to be positive. Now we go. Next one is a previous year JEE question. We have seen this. P is the left-hand derivative of mod x minus 1. So mod x minus 1 is minus of x minus 1. So left-hand derivative will be minus 1. So the limit of g of x should be minus 1. So I'll equate the limit to minus 1. And now when I try to find the limit here, because it is of the form 0 by 0, I'll have to use L'Hospital rule. So first step is this power m can come out. So my g of x will become x minus 1 power n by m log cos x minus 1. Now when you try differentiating, one by cos x minus 1 into derivative of cos, which is minus sine x minus 1. And this whole stuff should be equal to minus 1. So minus minus will get cancelled. Now sine x minus 1 must get cancelled with this term. That means n must be 2, because we know that sine x minus 1 by x minus 1 is 1. That means n has to be 2, so that 2 minus 1 will be simply x minus 1 power 1, and then they get cancelled. So n is 2. So once I understand n is 2, n by m is what will be the limit, because cos 0 is 1, right? So n by m is the limit, and n by m should be 1. So n and m both should be equal to 2. So that is the answer here. 78th question. It's again an easy one. We'll have to write f of x when x is slightly greater than 0. F of x will be simply g of x. When x is less than 0, it will be minus g of x. And now when we differentiate, so f dash will be g dash x or minus g dash x. So at 0, because g dash 0 is 0, right? And originally also g of 0 is also 0. So the function is continuous also here. And here g dash 0 is 0. So that means this will be 0, this will be minus 0, which is 0. So the derivative does exist and it is 0 here. The next question again is an easy one. If the function has to be differentiable, firstly, this function must be continuous. So let us evaluate what is the left-hand limit at 0. Left-hand limit will be x e power minus 1 by x minus 1 by x. So this is x e power 0, which is x. Now as x tends to 0, the value of the function will be 0. So that means a also should be 0. Only then it will be continuous. And only when it is continuous, it will be differentiable also. So the answer is a has to be 0. And the 80th question, greatest integer of tan square x. Whenever x is positive, tan 0 is 0. So when x is 0.001, tan of 0.001 will be a very small number. So greatest integer of that will be 0. And when x is minus 0.001, but because we are squaring the tan function, so tan of minus 0.001 will be a negative number, but the square will still be small positive number. So greatest integer will again be 0. So the function is continuous at x equal to 0. The limit does exist. So the answer is f of x is continuous. So the integer type we'll discuss in the next video. Thank you.